Now, as we have already defined what is inverse of function, let's define how to find inverse of a function. So here are the steps. So if we have a one-to-one function already given, y is equal to f of x, what are the steps? Step 1 is replace f of x by y. So I'm going to do this example along with the steps explaining. In place of f of x, replace y. That makes sense because f of x is y. The second step says interchange x between y. In place of y, write x. In place of x, write y. Let's do that. So in place of y, I have to write x is equal to 3 minus, in place of y, I have to write y. Step 3, solve for y. So we have to solve for y from this given equation, meaning now this is an expression x is equal to 3 minus y divided by y plus 3. We need to solve for y. So that means simplify the equation and find y, isolate y. So I'm going to write this as the x by 1 and cross multiply. That would get me this. My goal is to isolate y. Y is on both sides. Let's write it as xy plus 3x using distributive property. To isolate y, bring all the y terms on one side. Xy plus y is equal to 3 minus 3x. Now if you notice that y is a common factor in both of the terms on the left side. So if I can factor out y, x will be left in the first term. There is only y in the second term, it will be 1 is equal to. In the right hand side, 3 is a common factor. I can factor it out. It will look something like this. I need to solve for y, so I'm going to divide both sides by 1 plus x, and I'm going to get y is equal to 3 times 1 minus x divided by 1 plus x. So that is your last step. Whatever your y is, replace it by f inverse of x. So last step, replace y by f inverse x. That was our goal, to find f inverse function that is equal to 3 times 1 minus x divided by 1 plus x. Now there's a different kind of problem here. It's a graph of a function is given and the question is to find its inverse function. Graph the inverse function. Now before I do that, I want to make it in a point. If f is written as set of ordered pairs, if a point xy is on graph of f of x, then the point yx will be on graph of f inverse. Okay, so let's figure out. We have this question number 6. This is the blue curve is the graph of the function f. Let's find all the points. This point is 1, 4. This point x value here is negative 1, 2. This point here is negative 3, 1. This point will be negative 4, negative 2. Now let's write down all the points on f. We have negative 4, negative 2. If that point is on function f's graph, then f inverse will have a point called negative 2, 4. Similarly, we have negative 3, 1. This point on f, that means 1 comma negative 3 will be a point on f inverse. We have a point negative 1, 2 on f, that means 2 comma negative 1 will be on f inverse. We have 1, 4 on f, that means 4, 1 will be on f inverse. So let's mark those points on the graph. Negative 4 So we have to now plot these points of F inverse. X is -2, Y is -4. 1 point, 1, -3, 2, 2, -1, 4, 1. So now we can just join them like this. Now if you notice, this new red curve is the, what are we saying? This is curve of F inverse. If you notice here that F and F inverse are mirror images in this red given line, right? This red line is the equation of y is equal to x. So I want to make a note here that the graphs of F and F inverse are mirror images in the line y is equal to x, which is this line, the red diagonal line from the middle of your graphical grid. So F is graph will always be the mirror image of reflection of F inverse. Here in example number 7, we are given with the function m of x is equal to x squared plus 4 is where x is positive. So if you remember, we have x squared plus 4 is a graph of a parabola which is at 4 units above your x-axis. So that is the graph of the function. Now that function is not one to one, okay? But here is an important condition that x is positive. That means we are only talking about the right side of the graph. So we are only talking now, this function is one to one, and we can find the inverse of this function because of this condition. So sometimes they would restrict a domain of a function to make it look like one to one, so we can find the inverse of the function. So we have to find inverse of this function. Do you remember the steps? First is write y in place of the function. Step 1. Step 2. Interchange x and y. That means in place of y, write x is equal to y square plus 4. Step 3. Solve for y. So isolate y. I'll have to subtract 4 on both sides. I would get y square is equal to x minus 4. Now we'll have to take square root. So y would be equal to, now you know that when we take square root we have to put a plus minus sign, but if you remember we replaced x by y, right? So y has to follow whatever properties x is following. X is positive, that means y also have to be positive, so that's why we have to only take positive value. So y would be equal to square root of x minus 4. So actually you can draw the graph of square root of x minus 4. That would be the graph here. And as we just talked, that is the mirror image in the line which is y is equal to x. So this line here, if you draw y is equal to x, then this is the function of m of x and this is the function of m inverse of x. So whatever y you have solved, that m inverse x, because the function's name was m here. So that is x minus 4 is your answer. Let's do an application problem. The function defined by f of x is equal to 9 by 5x plus 32 gives the temperature Fahrenheit in where x is in Celsius. So basically it's a formula for converting Celsius into Fahrenheit. Determine the temperature in Fahrenheit if the temperature in Celsius is 25 degree. So in this case, x is given to be 25, we have to find f of 25. That's easy. 9 by 5 times 25 plus 32. This can cancel at 5. 45 plus 32, which will be 87 degree Fahrenheit. Part B. Write a function representing the inverse of the function. So we have to find inverse of this function. So we have steps for that. Write the function as y. That is step 1. Step 2. Interchange x and y, meaning we will write x in place of y. Step 3. Solve for y. So from the given equation, we need to solve for y. So that means we need to isolate y. I'm going to subtract 32 on both sides. We will have 9 by 5y is equal to x minus 32. Y would be equal to 5 by 9 times x minus 32. Whatever that y is, that becomes inverse of the function. That is the answer to the second part, inverse of your function. Write a function representing inverse of f. Interpret its meaning in the context. Now, what was f doing? So we had, what is x? X was temperature in Celsius. When we applied f on x, we got temperature in Fahrenheit, right? Now we have f inverse. This was applying f. Now in other reverse inverse function, what we have is the answer y, right? That was temperature in Fahrenheit degree. We are applying f inverse on it. What does that do? That gives us f inverse of x, which is temperature in degree Celsius. So we got you a formula which converts now. It is taking you from temperature in Fahrenheit to temperature in centigrade. Determine the temperature in Celsius if the temperature in Fahrenheit is F degree. So we have to apply F inverse on 5 because we are given in Fahrenheit it is 5 degree Fahrenheit. We want to convert it into Celsius. That function is F inverse. So what is the function? 5 by 9 times 5 minus 32. So 5 by 9, this is negative 27. This can cancel at 3. That means negative 15 degree Celsius is the answer. When it is 5 degree Fahrenheit, in Celsius it is 15 degree temperature. Okay. Let's review everything for this section. Given the function f, 1, 2, 2, 3, 3, 4, write the set of ordered pairs in f inverse. Pardon the printing. It says f inverse. We said if a pair is in f, then the reverse of the pair will be in f1. So 1, 2 is in f, 2, 1 will be in f inverse, 3, 2 will be in f inverse, and 4, 3 will be in f inverse. If a pair is in f inverse, then its reverse would be in f. The graph of a function and its inverse are symmetric with respect to the line y is equal to x. Because remember, they are reflection of each other in the line y is equal to x. If no horizontal line intersect the graph function f in more than one point, the function is called one-to-one function. Given a one-to-one function, if f of a is equal to f of b, then a should also be equal to b. Next, let f